we finished on the end of the indices and logs. Yeah. So we're starting a new chapter now, trigonometry then.
I think it's going to be very easy.
Trigonometry's okay, yeah. Alright. Hey. Hey. Listen. Yeah. Nathan, please. Yes. Your tutor's going to give you the results in individual tutorial.
You want the best?
What did you want, sorry? Oh, the answers. Ah, okay. Well, you know what? Maybe we can go through it in a tutorial then. So if you wanted to, I can print the test out and we can go through the questions in the tutorial this week then. Is that what you want? Yeah, okay. Yeah, so the tutorial this week will be the answers to the quiz then, okay? Yeah. Question? Your tutor will give you the marks then. Yeah.
Because for our group, we have 3 people per week.
Who's your tutor? Yeah, so you can get the results from him in the individual tutorial. But if you can't wait, if you want them sooner, you can get them from me. If you see me in the office, I can give them to you privately then, okay? So you can get them from your tutor, but if you wanted them sooner or you wanted them from me, just come see me in the office.
Yeah. When can I come? Tomorrow, right?
Yeah, see me, just come to the office tomorrow, and I can give them to you if you want. That's no problem.
Thank you.
Anything else, yeah? That's fine, so you can come see me in the office tomorrow and I can give you the results, no problem. Yeah. Okay. Tomorrow or whenever. Tomorrow is fine. I don't want to put the results on the notice board because I want it to be private. So this is why I said you can get them from your tutor or from me individually. Yeah. Okay. All right. So next chapter now, trigonometry. Guys, listen now. So trigonometry is next. This chapter is not too long and it's not too difficult. We have some basic definitions to do today, so this lesson is quite an easy lesson to start with. The first thing I want to look at is how to measure angles. Well, you know a basic unit already to measure angles is degrees. Come on. There we go. Here we are. So, trigonometry. So the first thing to talk about is how to measure angles. Come on, who's making all that rustling sound? You're doing that... Now you just drew attention to the fact that it's you by looking around. Alright, okay, fine. You're off the hook. Right. So measure angles here. We can use something called degrees, and this is something that you learn about since elementary school. So like this one here is maybe about 30 degrees, something like that. But there is another unit we can use to measure angles. It doesn't have to be degrees. Does anyone know this other unit to measure angles? Yeah, there's another unit called radians. And the definition of a radian is that 2 pi radians is equal to 360 degrees. Or if you want it in decimals, it's roughly 6.2830 radians is roughly 360 degrees. So you can see a radian is actually quite a big unit for measuring angles. Because in degrees, one circle is 360 degrees, but in radians it's only about 6.3 radians. So a radian is quite big. I think something like 1 radian is about something like 57 degrees. So a radian is quite a big angle. It's about that much, it's a big chunk. Does anybody know the reason why radians might be used though? Like what's wrong with using degrees? What's the advantage of using radians? Does anyone know why you to use radians? Yeah, what about it though? Like what's the usefulness? No? 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 The advantage for using radians is, let me draw an example here. Yeah, what is it? Do you know? Something. Yeah. I'll tell you. So, for example, if this was measured in radians, so let's say it was just 1 radian, and let's say the radius here is 1 meter, then it means this part of the circle is also 1 meter. So, in other words, if you knew the radius and you knew the angle, then you can know what's called the arc length. It's the radius multiplied by the angle. But this only works if you're using radians. It doesn't work if you're using degrees. So this is the advantage for using radians. This isn't something we'll deal with though, so you don't need to worry about that. We'll just worry about converting from degrees to radians. A second important thing before we have a look at some examples is the units. So you can write radians like this, 1 radian, and for example this is 30 degrees, but you don't actually need to write the word radiant afterwards. If I just wrote the angle equals 1, then without writing the degree symbol, that automatically means it's radians. So if I write theta equals 1, that automatically means radians. And if I write theta equals 30 with the little circle here, that means it's degrees. And a very important point here. So, in maths, this is really important. In maths, radian is the default angle to use. And by default I mean, if you don't know what one it is, it's radians. In other words, it's not degrees that's the basic one and radians that's the new one. It's the other way around. Radian is considered the basic unit to measure the angle, and degree is the special, unusual unit. Okay, so I think the problem is because you learn degrees first, you think this is the normal one to use and radian is the special one. No, you need to think about it the other way. Radian is the normal angle to use in math, and it's degrees that's the special one. Okay, so if I don't tell you what the unit is, it means it's radians, because this is the normal one to use. It's degrees that's the special one, and I need to tell you with a symbol that it's degrees. Okay, and I'll say that again. Radians is what you normally use. Okay, this sometimes causes students a problem in the exam, because the question might say something like theta equals 2, and everybody forgets that it's not degrees. They leave their calculator in degree mode. Really, it should be in radian mode. Okay, so please remember, radians is the normal measurement of the angle. Okay, let's have a look at how we can convert from degrees to radians. It's not that difficult. So if you have degrees and you want to convert it to radians, what you do is you multiply by pi over 180. And if you have radians and you want to go to degrees, you could divide it by the same thing, or I prefer multiplied by 180 over pi. So let's just do a couple of basic converting examples here. So let's say I have 100 degrees, and I want to convert it into radians. So that would be 100 degrees times pi over 180 degrees. Yeah, what's that? Do you have it there?
Yeah, 1.745.
1.745 radians. Okay, let's try this one. I have 8 pi over 15 radians, and I want to convert that into degrees. So that's 8 pi over 15 multiply 180 over pi. What do I get there, please? Can someone type that in?
96.
96 degrees.
Yeah.
And one more example. Let's say I have 2.6529 and radians, and I want to convert that into degrees. So it's 2.65929 times 180 over pi, and what do I get there?
151.99.
So 152 then degrees. So here's some examples of converting there. Please write those ones down. We'll have a look at something else now. Okay. You have these examples? Yeah? Okay, can I scroll down? Yeah. Okay. The next thing to do, again, this lesson is very easy. I'm only going to give it a few minutes. Is Pythagoras Theorem. But I think I've mentioned it at least once already. So, just to give it to you, I suppose clearly now, the name of this type of triangle is called a right angle triangle. This symbol here means 90 degrees. When you have this this type of triangle, if I call, for example, this x and this y and this z, there's actually a simple relationship between the three. It's that x squared plus y squared should equal z squared. This is actually called Pythagoras Theorem, and it's something that you've all learned already in middle school. So let's just do a couple of examples of this. Write this one down, please. Now, what's actually useful about this theorem, true, it can provide a way to find a missing side, but it also provides a way to check if the triangle is right angled as well. So it actually has a few uses to it. Can I scroll down? This one here, x side, y side, and z side. Yeah. X squared plus y squared equals z squared. This is right angle here. Yeah. Okay. Continue. Yeah. For example, if this side is 5 and this side is 12, and we want this side 13, yeah, Pythagoras says x squared equals 5 squared plus 12 squared. X squared is 169, so x equals 13. Or this one here, if this is 3, no, let's not do it. Let's say 6 and 10, and we want this side, we have 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. X squared equals 64, so x equals 8 then. So there's 2 more examples, if you can write these down, please. Yeah. Let's see. Oh, are we talking about the last step here? Yeah, I square rooted both sides. So square and square root cancel, and then root 64 is 8 then. Okay. let me give you an example where we can use Pythagoras to check if we have a right angle triangle.
You just give it to moment.
Yeah, okay, yeah. Yeah, we'll come back on now. Shh. No. There it is back there. See, everything is okay.
Everything's
Everything is okay. Right. Do you have this one now? No, it's
Everything's
just
okay. I know.
it just wants the password, that's all.
It is,
Okay.
it's,
Yeah, the password is ST, yeah.
H.
Yeah, no, almost, yeah.
Okay.
Okay, there you go. Right, it's all fine. Okay, so we'll do another example now after this one. How we can use Pythagoras to check if a triangle is right angle as well. Okay, can I scroll down? Yep, okay. So for example, say we had a triangle, but we're not sure if it's right angle. So maybe the sides, for example, could be something like 2, 3, and 4. And we don't know if it's a right angle. We can use Pythagoras to check, because 4 squared should still equal 2 squared plus 3 squared. So 16 equals 4 plus 9, so 16 equals 13. So because this is false, it means that it's not a right angle triangle. And this is useful. This is a useful, simple way to check if the triangle is right angle, if Pythagoras is still true. Okay? So write this example down. It's a very useful example. Okay, you have this? Right, so, yeah. This one here. Will I do another example, or just this one again? This one, yeah. So what happens here is you have a triangle, and I give you the sides 2, 3, and 4. And you don't know if this will make a right angle. That is, you don't know if the angle here is 90 degrees. So the way you can check is by using Pythagoras. The longest side squared should equal this squared plus this squared. It should equal it. You get 16 equals 4 plus 9. And you can see that the result is wrong. 16 does not equal 13. So because it's false, we say it's not a right angle. If it was true, like for example here, next example, if this was 5, this was 12, and this is 13, 13 squared equals 5 squared plus 12 squared, 169 equals 25 plus 144, 169 equals 169. This is true. So it means this is a right angle up the top here. Yeah. If there's going to be a right angle, the right angle is always opposite the longest side. So if there is going to be a right angle, it should be opposite the longest side. Okay, did you write this one, this example down? Come on, write it down. Okay, you have this? Yeah? Okay. So far we've looked at finding missing sides. Now we need to look at how we can find missing angles. I can go down a bit yet? Now, it's not the only way we'll have it, but if I know one of the angles, if I know two of the angles, I can easily find the other angle, because the total should be 180. So here, 30 degrees plus 90 degrees plus x degrees should equal 180 degrees. Yeah, so it has to be 60. You get x equals 180 minus 30 minus 90, so x equals 60. So that's fine. But we're going to have a little bit of a problem if we have some situation like this. For example, this is 90, maybe we have something like this angle is 30, we'll say this angle is 60, and let's say this side is 10, for example. There's a problem here. I'm missing two sides, and for Pythagoras to work, I need to only be missing one side. There is a way we can use the fact that we know the angles to help us. Yeah. We can use something you've done before called sine, cos, and tan.
Yeah.
So let's have a look at that. Yes. Right. So just a little bit of vocabulary. If this is the angle here, I'll call it theta. This side has a name. It's called the opposite. This, because it's opposite, of course. The longest side has a name. Hypotenuse. And this side here, adjacent, yeah. Guys, listen. So just for vocabulary, we have the names of three sides here: opposite, adjacent, and hypotenuse. So what we're going to look at is how the sides can be related, their relationship. For example, you have the possibility of doing comparing the opposite with the adjacent. So you can look at the opposite compared to the adjacent, or you could do opposite with hypotenuse. How many possibilities do you have here of comparing one side to another side?
6, 7, 8, 9.
No. Well, think about it like this. On the top, how many possible sides do you have? You could put opposite, adjacent, or hypotenuse on the top, right? So you have three possibilities here. How many possibilities for the bottom? 3. So in total, there's 9 possibilities.
9 people.
Shh. Be quiet and just look. Look. On the top, you could have opposite here and opposite here. Now, this comparison we won't bother with because it's always going to be 1. But you could have opposite over adjacent, and you could have opposite over hypotenuse. Or you could have adjacent over opposite, adjacent over adjacent, adjacent over hypotenuse. And final 3, opposite over, hypotenuse over opposite, hypotenuse over adjacent, and hypotenuse over hypotenuse. Now, 3 of them we can automatically cancel as not being important. This one, and this one here. So we could look at opposite over adjacent, opposite over hypotenuse, and then the other one here, adjacent over hypotenuse. And you realize the other 3 aren't really that interesting because adjacent over opposite is really the same as opposite over adjacent. You're just looking at it the other way around. So this one doesn't really add anything new. Neither does this one. Neither does this one. So these are the 3 comparisons we can care about, and they're each given a name. So when we take the opposite and divide it by the adjacent, that's given a name. This one is called the tan. Or the tangent of the angle theta. The opposite divided by the hypotenuse is called the sine of the angle. And lastly, the cosine of the angle is the adjacent divided by the hypotenuse. So please note these 3 here. Okay, do you have those 3? Yeah. I'll scroll down a little bit. So let me just give you an example of how to calculate. In this triangle here, this is 90. This side is this angle's 60, this angle's 30, this is 1, this is 2, and this is square root 3. So let's have a look here. In this triangle, the sine of 60 would be the opposite, which is root 3, divided by the hypotenuse, which is 2. Now, your calculator has a sine function on it. So if you type in sine of 60, do you get the same thing? What do you get?
Yes, same. Magic?
Root 3 over 2, yeah? Yeah? Okay. What is cos 60? 1 over 2. Yeah. Huh? Kind of, but I mean, we have the calculator, so we don't need to have the tables. This one here? No, but you have your calculator, so you can just type it in. Listen carefully. Do you have a calculator? Do you? Do you know how to use the calculator? Can you type in sine 60? Then why would you need to memorize what sine 60 is? Yeah. Right, so what is tan 60 here? Root 3 over 1, which is root 3. What's sine 30 in this one? It'll be 1, because this is the opposite, 1 over 2. What's cos 30? Root 3 over 2. And tan 30?
Is 2.
Tan 30 is 1 over root 3. Okay? And if you were to take out your calculator and type in sine 60, cos 60, tan 60 and all this, they'll be the same. They'll be the same. So, let's have a look at how we could use our calculator to help us find missing information. Okay? Can I scroll down? Yes.
Question. I think triangle 8, I don't think you continued it. After that,
The number 8 I did?
Yeah.
I'll go back to it in a bit, don't worry. Actually, let's have a look here. Oh yeah, number 9, was it? Yeah, I'll get to... Actually, yeah, let's do number 9 now. We have enough maths to do number 9. Example 9. So let's say I would like to find this missing side here, x. And then later I'll find this side here. But first let's focus on the x. So we have a choice here. Because I know all the angles, I have quite a lot of options here. But the only side I know here is the 10 and the x. So, if I was to use 60, I would have to use something that uses the adjacent and the hypotenuse. If I use 30, then I have to use something that uses the opposite and the hypotenuse. So let's use 30. What uses the opposite and the hypotenuse? Sine, yeah. So sine 30 degrees should equal x over 10 from the definition of sine 30. But if you take out your calculator, hit in sine 30, what's sine 30? It's a half, isn't it? So you get a half equals x over 10. So then x equals 5 then. Yeah?
Can we know because the angle is 30, so it will be the half? No.
Yeah, it's always a half for sine 30, yeah.
So I don't need to...
You don't even need a calculator if you remember sine 30 is a half, yeah. Right, let me give you one that's like this to try. Sorry, I said I'll get the missing side y. So what would be the easiest way to get this side? We could use Pythagoras, or we could use a sine cos tan, but we'll just use Pythagoras. Y squared plus 5 squared should equal 10 squared. Y squared plus 25 should equal 100. So y squared equals 75. So y is square root 75. That's 5
root 3.
5 root 3. Yep.
Sorry, could you tell me again why you chose 30 and not 60?
Oh no, I could have done it with 60 and I would have got the same answer. So for example,
If you use 60, what?
Yeah, if I use 60, so if I use 60, I'll have to use cos, because this would be the adjacent side, and this would be the hypotenuse. Adjacent means neighbour. So if you look at the 60, the relationship between x and 60 is that x is its neighbour. So it's called the adjacent. You would have here cos 60 equals x over 10. Isn't that right? Yeah, cos 60 equals x over 10. And if you take out your calculator and type in cos 60, it's a half. So you get the same answer. So you have a choice. You can use sine or cos here. We'll do another example. Here, you try this one for me. I'll draw the triangle here. Let's say this side here to here is 2 meters, and this side is x, and the angle is 40 degrees. I would like you to calculate the x. Give that a try, please. Okay. So, which should we use? Sine, cos, or tan? Tan, yeah. We can say tan 40 degrees equals x over 2. So then that means 2 multiply tan 40 degrees equals x. So what do we get for x, please? 1.678 meters. Then. If you're using radians, you can. Just make sure your calculator is in radian mode. It's no different if these were in radians. Okay. Now, next I want to show you how you can find the missing angle using sine, cos, tan, yeah?
I'm sorry, if you're using radians, you should use tan.
Yeah, you still would use tan. The process is the same, just make sure your calculator is in radian mode. So for example, look here. Let's say this here is 3 meters, and this is x, and this angle here is 1 radian. So here we still have tan, but it's not tan of 30 or 40. In this example, it's tan of 1 equals x over 3. So x equals 3 multiply tan 1. So just make sure your calculator is in radian mode, and then you should get the right answer. It's usually something like shift mode radian.
Or maybe just use the...
Or you can convert it back to degrees.
By times it by 180.
Over pi, yeah. What do we get here? 4.67 meters then. Yeah. Okay, can I scroll down a bit? Yep. Okay. The next thing now is, if you have the sides, let's say this is 4 and 5, and I want the angle now. Well, you could use Pythagoras to get this side, but that doesn't help you work out the angle. We have to use sine, cos, and tan. So in this example, which one am I going to use? Sine, cos, or tan? Tan. So you can say tan A equals 5 over 4. Or if you want, tan A equals 1.25. So here you want to know tan of what angle will equal 1.25. And in this example, you're working backwards. You want the original angle so that the tan of it makes 1.25. There's a special function on the calculator, which is exactly what you need for this situation, called tan inverse. Yeah. So tan inverse of 1.25 can give you the missing angle. 51.34 degrees.
No.
No?
No,
No?
no point. No, no point eight.
Are you still in radian mode?
You're in radian.
Ah, radiant. Yeah.
51.3
4.
degrees. Yeah.
Both are correct or no?
Both are correct, yeah. So if you gave the answers radiant, that's fine. What was the answer as a radiant?
0.89.
0.89.
Is it?
Yeah, so that's fine as a radiant. Yeah. Both are acceptable. If the question didn't say, then both are okay. Yeah. Okay. So I'll let you try some of these now. I think they're very, very simple. You should get them done in like 5 minutes. So D, E, and F then in each question. Now the last one is a little bit hard, and I want to see how you do it by yourself, and I can do it in the next class. Question number 5 is tricky. You cannot use your calculator in number 5. This is what makes it hard. But try it anyways. D, E, and F. If you can just do those for a few minutes. D, E, F, and H, yeah. Be strong.
I am tired.
I know, me too. D, E, F.
Oh, that's it.
Yeah, well, I stayed up until 2 a.m. watching the results coming in,
Oh,
so...
So you were worried.
Huh?
Disappointed or are you happy?
I was what?
You were worried.
No, not worried. It's just interesting to see how it goes. And it still wasn't finished by 7 o'clock this morning, so... It wasn't until 8 o'clock.
My family's American, so,
Are they? Alright.
yeah.
Can they vote?
Yeah, again, half
Yes.
of them, the ones that are eligible.
All pro-Trump, yeah? Yes,
Sure.
They had the banners and Trump 2016,
Oh, yeah,
yeah.
the Muslims, they love Trump.
Yes.
That's
He's popular with the Muslim community in the States, isn't he? Yeah.
My uncle, he's brown, so yeah.
Oh yes, they get along just
Brown
great,
people.
just great.
Do you like Trump?
Of course not.
Yeah.
It's a horrible person.
I don't know how.
Oh wait, I have that. I have that on the record now since it was recorded. So.
Oh,
Take it off.
I know.
You know what? Fear Trump to know.
Yeah, that's good. Because you'll come.